As a final way of thinking about hypothesis testing, I want to focus on two things. The first being differentiating the types of error that we are inherently going to incur during hypothesis testing, and the second, which is the overlap between the concepts that we learned in previous modules with regard to confidence intervals and hypothesis testing. So, with regard to the first consideration and the types of different errors that we may incur, I want you to just try to imagine that we're all jurors sitting in a jury and we need to determine how to sentence someone based on the possibility that they may be innocent, even if we want to convict them. And you can kind of think of this outcome in a 2 by 2 table, right? Where there's the truth, this person may be guilty or innocent, and there's our decision. We are going to have to decide whether this person is guilty or innocent. And we may get that right, so the person is guilty and we convict, or the person's innocent and we let them go free. Or you can imagine a scenario in which the person is innocent and we convict them. That would be a very horrible situation, right? And we typically don't want to incur that type of error. Now, there's a second type of scenario where the person may be guilty, but we say that they're innocent, and that's type 2 error. And typically, that's the type of error that we're more willing to incur. And I think this example kind of drives that home point more. Now, that's not to say that there aren't necessarily trade-offs, right? Like when we have type 1 error, we're rejecting a null hypothesis when the null is actually true. That's not necessarily a good thing. And with type 2 error, we're we're failing to reject the null when the null is actually false. But again, we tend to prioritize reducing this type 1 error, even though there are different types of trade-offs. And I think this visualization kind of helps to drive the way in which we connect hypothesis testing and the different types of errors. So you can imagine like we have any different sample mean, it doesn't really matter. There's always going to be a chance, right, that we actually have overvalued the mean, and we're probably going to reject the null hypothesis that it's something else, when in reality, that null hypothesis actually is the true underlying value. Whereas sometimes we may underhit it and we're going to get some type 1 error. Regardless, we're going to have to live with these different trade-offs and think more concretely about what's going on. So with type 1 error, right, we're estimating the probability that given the null is true, we're rejecting that null. That is going to be represented by our critical value, our alpha. This is our primary focus, right? The harder thing to do is to consider, given that the null hypothesis is false, we fail to reject that, right? Because the null could be false for a bunch of different values. One way in which we try to overcome this is to kind of calculate the strength or the power of our hypothesis tests, and that's considered kind of 1 minus the probability that type 2 error is going to occur. So essentially what we're doing is we're trying to say, given that an effect is actually there, what is the probability of us finding it? And in a lot of cases, this is done for an experiment, right? Like we want to know if we're just wasting our time because we don't have a sufficient number of observations. So even if that relationship is there, maybe that medication is efficacious, but we'll never be able to know it because we don't have the statistical power to even detect it. I think the most important thing to walk away from with this is that there's always going to be a trade-off between type 1 and type 2 air, and just to remember that this is what's happening in the background. So even though we may think we have sufficient evidence to reject a null hypothesis, really there's still a chance that we're wrong, and we need to understand how that works.